study about the important analytical technique, that is going to be centrifugation. Centrifugation is going to be an important process which is going to be occurs in the centrifuges. So the centrifugation is going to be taken place by the two principles. These two principles united to be known as sedimentation. A major principle aligned in the centrifugation is sedimentation, which is known to be a settling of biomolecules. So during the centrifugation in the test tube, there is going to be a biomolecules are going to settle off in the test tube. This settling of biomolecules are very important, which is known to be sedimentation. This settling of biomolecules is very important for the isolation of biomolecules. So this sedimentation or settling of biomolecules are going to be taken place by two principles, two forces to be involved in sedimentation principle. They are gravitational force and centrifugal force. These gravitational force and centrifugal force are very important for the sedimentation of biomolecules. In general, without these, centrifugal force or also a settling of biomolecules to be taken place. When there is no centrifugal force, in the absence of centrifugal force, the sedimentation is going to be occurs at the increased time. That is, more time is needed for the settling of biomolecules in the absence of centrifugal force. But in the presence of centrifugal force, that is, by the combined action of centrifugal force and the gravitational force, the biomolecules are going to be sedimented off within the decreased time. That is, a centrifugal force are going to cause the decrease in time for the sedimentation. So the centrifuges are used for the sedimentation of biomolecules by the combined action of gravitational force and centrifugal force. This combined action of gravitational force and centrifugal force causes the sedimentation or settling of biomolecules. So at first we have to know what is centrifugal force. In general, gravitational force, we have know that there is going to be a certain force or gravitation occurs on the all objects, where a centrifugal force is found to be a force which causes the sedimentation, where the object, that is going to be a biomolecules, here the object is biomolecules, are going to be settled off because of the circular motion of object. The object is going to be in the circular motion, where there is the axis. This axis is found to be a rotor. Due to this axis, where there is an axis, causes the rotation of biomolecules, which causes the biomolecules to sediment off towards the outward direction, which causes the biomolecules to move off on the outward direction. This outward direction of biomolecules movement which causes the sedimentation of biomolecules. This sedimentation of biomolecules due to the circular motion which is known as angular velocity. This circular motion of biomolecules is known as angular velocity, which causes the movement of biomolecules to the outward direction, lead to sedimentation. This circular motion at the steady angular velocity which causes the movement of the biomolecules is known to be a centrifugal force. So here is the image for the depiction of how does this centrifugal force occurs. So this is going to be an axis. In this axis there is going to be a circular motion. This motion is known to be angular velocity, which this angular velocity causes the movement of molecules towards outward direction. This outward direction causes the sedimentation of biomolecules, which is known as centrifugal force. This angular velocity which causes sedimentation of biomolecules, that is centrifugal force, is depicted by the formula F is equal to omega square r, where omega is found to be an angular velocity R is going to be a radius or distance from the central basic principles of sedimentation. So the basic principle of sedimentation depends on the gravitational force, and another is going to be a centrifugal force. So the centrifugal force is going to be depicted by a formula F is equal to omega square R, where omega is known to be angular velocity, where the object is going to be in the circular motion for the particular time. So the object is going to be circular motion, which is known to be revolution per time. So the angular velocity is depicted by revolution per time as a unit. So omega is equal to 2 pi rpm divided by 60. So this omega value is going to be substituted in F is equal to omega square R. We can get the result as 4 pi square rpm whole square into R divided by 3600. Next, we are going to see about the gravitational force, because a combined action of gravitational force and the centrifugal force together, which causes the compound to settle off, which is known to be sedimentation. So as we know the centrifugal force formula, now we have to apply the gravitational force along with it to find the sedimentation formula. So this sedimentation is depicted by the unit of RCF, which is relative centrifugal field. Relative centrifugal field, which means there is a relationship between a centrifugal force and the gravitational field. So the gravitational field and the centrifugal force together causes a relationship. This together relationship causes a sedimentation, which is depicted by the unit of RCF. So the RCF is equal to 4 pi square rpm square divided by 3600, where the gravitational force is going to be depend on the 980, which is the value of gravitational field in standard condition, into R, which is the radius of the particle. So this RCF is going to depend on the ratio of weight of the particle in the centrifugal field, which is this value, and the ratio of the weight of the particle in the gravity alone. These both together is known to be RCF, which is important for sedimentation. So in general, the RCF is going to be depend on RPM, which is revolution per minute, depicted by omega, depicted for angular velocity. Then the radius of rotation. The radius of rotation is going to be a rotation to be occurs where the rotor is in central axis, based on from the central axis to the test tube there is a certain distance or radius. This distance or radius is found to be the radius of rotation. Then the density of a particle. Density of a particle is biomolecules density, and the density of a medium. A density of medium is very important in the case of differential centrifugation, because they uses a different types of medium during this differential centrifugation for the sedimentation of different biomolecules. Then the viscosity of the particle. So the viscosity of a particle is going to depend on the thickness of the particle. Due to the viscosity of a particle, they causes a mode changes, which causes a friction, which lead to changes in the RCF. So the revolution per minute, radius of rotation, density of a particle, density of a medium, viscosity of a particle, and radius of the particle are the important factors to be involved for the sedimentation of a particle, which is depicted by the RCF. Next, when we consider a biomolecules to be as spherical, because mostly the biomolecules are spherical in nature. These biomolecules are spherical in nature are depicted by the formula of force F is equal to 4 by 3 pi r cube, because a spherical molecule can be depicted by 4 by 3 pi r cube. where r is going to be a radius of the particle, and p, rho p is known to be a thickness of the particle, and rho m is going to be a density of a particle, rho m is going to be a density of a medium, and omega square r, which is angular velocity and radius of a particle. Together is found to be a formula of force applied to the biomolecules, which is spherical in nature. Next, if the particle is going to have the viscosity, the particle has a medium which is going to be have viscous in nature. When the particle medium is going to have increased viscosity, then the sedimentation is going to be decreased. So this viscosity is considered when there is a medium with viscous in nature. This viscosity causes the frictional force. This frictional force causes a sedimentation to be decreased. So this frictional force is depicted by F naught is equal to Vf, where V is going to be a velocity of sedimentation which is going to be affected by the friction, and F is going to be a frictional coefficient. So this F, frictional coefficient, is depicted by the formula 6 pi eta Rp, where eta is going to be a thickness, Rp is going to be a radius of the particle. So when this frictional coefficient formula is going to be applied, frictional force is going to be applied to the given formula of friction. This frictional coefficient is going to be applied to this given frictional force formula. We can get F naught is equal to V6 pi eta Rp. So this frictional force is going to be equivalent to the F, that is angular centrifugal force. This centrifugal force is equivalent because this frictional force causes a decrease in sedimentation because of it affects the centrifugal force. So we can get the velocity, that is sedimentation velocity, to be taken place, that the sedimentation changes to be occurs due to the frictional force. So this is a sedimentation velocity to be found if there is a friction to be applied. So from this we can found that when there is a particle is larger, faster it moves and the sedimentation is going to be faster, because a particle velocity is going to be directly proportional to the sedimentation velocity, and the particle medium is also going to be equivalent to the velocity. So more denser the particle, the faster the sedimentation to be occurs, and denser the gradient or solution also causes the faster the velocity, but a viscosity is going to decrease the sedimentation velocity. So the viscosity is going to be inversely proportional to the density of the medium, viscosity of the medium. So the viscosity is going to affect the sedimentation velocity. Otherwise, the radius of a particle, the radius of the medium, the radius or distance from the central axis to the particle, and the angular velocity and radius of the particle all are directly proportional to the sedimentation velocity, because they are all equivalent. They are all directly proportional, but a viscosity is only going to affect the sedimentation velocity, which is inversely proportional. The higher the viscosity of a medium, then there is a lower in sedimentation of a particle. So the slower the particle will sediment when there is a higher the viscosity of a medium. So the time taken for the sedimentation can also be depicted by 9 by 2 eta divided by Rp square rho p minus rho m into omega square r, because it is based on the viscosity, the time is going to be proportional. So based on the viscosity is going to be proportional to the time, we have created this formula to identify the time based on the viscosity. This is going to be a sedimentation velocity formula. This is going to be a time taken for the sedimentation. So in this video we have found we can understand the principles and the formulas to be involved for the centrifugation process and sedimentation process to be taken place in the centrifuge. Thank you.